Okay, so I'm going to start here with, I have basically our version, or the version that I've been editing live here of the original Control 3D base. I have this add-on here. I'm going to wait a little bit before I use that. Maybe I'll even switch videos and put it in the beginning of the next one. I want to begin instead by looking at something that can really optimize the rendering of our objects. So I've talked about earlier that if we go into base 3D objects here and look at something like the cube or the sphere, it doesn't matter which, that this part here, where we're actually taking this data from arrays and sending it to OpenGL, sending it down to our hardware, that's what really takes time. Obviously drawing does as well, and we want to optimize that, but OpenGL optimizes that for us, and OpenGL, all of this is happening on the hardware when we draw it. So we split this up in order to do this as few times as we can. However, I want to optimize it even further by actually only doing this when we load the object, like sending it to the hardware, and instead of actually having this array that we store, we simply send it to the hardware. We have OpenGL write it on the hardware memory in the graphics hardware, and whenever we want to access it or bind it, we simply send an ID to it and say this is now what we want to use. So we never have to send this again. And we're going to do this by using what's called Vertex buffer objects. So basically when we generate this, I'm going to do this with the sphere here. The good thing about this is we don't have to change our shader at all. Our shader is still just taking the attribute. We're just changing the way we have the attribute read into the shader. So the first place we want to look is the initialization here. I'm going to look at this sphere, and it's basically in this for loop building these vertices. We have one vertex here, and we have another vertex here, and then it goes through a loop and basically goes around the circle for the basically width between two latitude lines on the globe, and then it moves up. All right, so we're just loading these, and it doesn't matter how we load these. We can do it this way. We can do it like we do here, where we simply hard code this position array and normal array. The thing is, afterwards, we've loaded this into our array here, and we don't do anything else with it. Then every time we're going to draw, we set the vertices, and we send these arrays down to OpenGL. What we want to do instead is build this buffer object here. I'm going to unzip this here, and I'm going to make sure I have, sorry about this, just to have a backup here to make sure that no, it's not in here, it's in here, 3D objects here. Just have my backup here. We can even look at what it looks like after we've made the changes here. I can even do this again and just make another copy of it. Okay, so the first thing I'm going to do, just do it the same way I did before. I'm going to take this sphere class, and then we can actually compare. It's very interesting to compare what effect these changes have. And I'm going to call it the optimized sphere. So once I've loaded these arrays here, I am going to just copy these lines here and explain each one as we go. So what I'm doing here is we're basically telling OpenGL I want to make space, make room for a vertex buffer, or I just want OpenGL to give me an ID to a vertex buffer. And OpenGL will basically handle whatever data is behind this ID in any way it wants. So we can call GL gen buffers like this. It's also possible to call it with a higher number. This is basically saying, give me one buffer. If we want to make more of them, we basically set a higher number, but then we have to send in an array of integers. And the integers in that array will be updated for us. And the output will basically be all the numbers there. It's simplest to just use this every time. It's not that much of an optimization to do it for many at a time. So we have this vertex buffer ID now, instead of just our array. So all we've told OpenGL at this point is just, I need a buffer. We haven't put any data in it. We haven't done anything else with it. The next thing we want to do, and we want to do this actually several times also when we draw, we're now telling OpenGL the array buffer object that you internally should be using now, it's basically a state that I'm setting, should be the vertex buffer that has this ID. So OpenGL has a single, basically array buffer, internal buffer that it will use at any given time to read this data from. And I'm simply telling OpenGL, I want your current array buffer to be the internal buffer that you have and has this ID. And you've given me this ID, so I know that you have something there. So now I'm binding it without there being any data in there because I want to set data to it. And so the next line here, it's a function called GL buffer data. That's just telling OpenGL, I want to put data into whatever buffer is currently active in OpenGL now. So I've set this buffer, this empty buffer, as the currently active buffer. And now I say for GL array buffer, this is just saying what active buffer it is in OpenGL that we want to set. Now this is the only part I've kind of been avoiding needing to use NumPy or other kind of array-based libraries or math libraries. I've tried to do everything with as much native Python as we possibly can. But in this case, just to make sure that the types are correct and the types take the right size, and we can there is one trick when we draw this where we need to make sure that the size of each item is exactly correct. We need to make this specifically typed NumPy array here with this type float32. So one more thing we need to add up here is we need to import NumPy. And if you haven't already, you can go in here, either in any console, do python -m pip install NumPy, or if you're inside this console, you shouldn't even have to do that. Python, you can just do pip install NumPy. All right, so import NumPy, just to be able to send this array in exactly the correct format. So we're saying OpenGL, all right, this active array buffer should now get this data. GL static draw is kind of just a hint to OpenGL about how we're going to be using this. And GL static draw tells OpenGL we're probably not going to be changing the data in here. So you can store it in a way where you don't expect to need to do fast changes to it. It's just going to be like this the entire run of my program. Questions regarding this? One more thing I do here, and that's simply because right now I'm just adding this to the sphere, so there may be other things drawn that are not using this internal GL array buffer, but instead sending the arrays like we did before. If I don't do this last line here, where I'm basically binding GL array buffer to 0, which means I'm basically unbinding it. I'm saying there is no active buffer now behind GL array buffer. If I don't do this, then all the objects that don't use this method of sending things in will simply disappear because OpenGL won't know where to search because it's still searching that active buffer, or it'll use other things than we expect it to. So this is simply me unbinding GL array buffer in order for the other stuff, like the cube here, which is still just setting this UV array normally with the set UV attribute. We want that to still work. All right. So what we've done here is basically we've taken the data from the array, and instead of just storing the array, we've stuffed it into this buffer. And we should be able to do one more thing here, actually. Should be able to say vertex array equals none. Well, it's not self vertex array anyway. So okay, we could do vertex array equals none, or self vertex array equals none. We can also just say this is now just a local variable here, because we don't need to store this array anymore. We've sent the data from it to OpenGL and we want to use it from there, so we don't need to store it internally anymore. Let's just do it this way instead. Make sure that the garbage collection will just take our original data anyway. All right. So this is what we do when we basically load this. We're sending this data into OpenGL to be used internally. That also means that we need to make changes to this stuff here, where we have functions on our shader, operations on our shader that basically take the array in. So I'm going to go in here. I'm going to look at these operations, like set position attribute and set normal attribute. There we call GL vertex attribute pointer for the position attribute location, and we send in this vertex array. Now we're going to do this a little bit differently. I'm going to go just go back into here, here, and into the mesh model add-on. And now I'm going to steal a little bit of this. So let's start with adding this import here. So this is the GL utilities library. I'm just using one specific thing from that, also because of these array formats that we need to use, and actually kind of C++ implementation leftovers that we need to work around. We're here. Then I'm going to simply steal this. Okay, so what we're doing here is we're taking actual array data and we're sending it into OpenGL, and we're doing that every time we're going to draw something. Instead here we want to say, all right, I'm not going to send an array using GL vertex attribute pointer. Instead, and right here, I'm actually going to erase this for now, make a simpler version of it now, and then we'll make this more complex version later to explain a little bit. All right, so again, we call GL bind buffer, which means we're saying this vertex buffer ID that we get in. Yes, question? Here. The question is, do I not need to unbind it here? If I were to unbind it here, I'm unbinding it before I draw using it. So yes, I do, but I don't do it in this function, I do it afterwards. So here I'm setting it. I'll show you where I unbind it, but yes, it's very true, you need to do that as well. So I'm telling OpenGL, instead of here where I'm sending an actual array in, here I'm just sending this ID, and I'm telling OpenGL, bind to this ID where I've actually put my data already. Then I call vertex attribute pointer with exactly the same information here. All the same information, except I'm going to also take this out and just say 0. So everything is the same, except instead of sending a vertex array in, I just say none now. So I'm just saying, I don't need to send anything in. You are bound to a vertex pointer, and that's what you're going to use. So I bind to the vertex pointer, and then I make sure that these actually don't have arrays behind them, but instead they have nothing behind them. Or in C++, this will be kind of in the underlying C++ implementation, this will be interpreted as void pointer 0, something like that. So this in and of itself means that we can, instead of sending an array down there, we can just tell OpenGL you already have the data. So everything happens internally. The only thing I need to send down is just a tiny little ID instead of sending all this data. Then we can go back into our objects here. So I'm simply going to take, well, we can have set vertices here, since we're calling that probably already. So again, I'm going to go in here and look at what I do to draw. So I do all of this same stuff, except instead of calling this, I call this. There's one thing that I'm doing here that I can't really do otherwise because this is the sphere. Because I'm using the same exact coordinates for the positions and for the normals. Because the position is just kind of a displacement from the center. So I can use that same coordinate as a normal that points in the same direction from the center. So for most things, there are different coordinates for the normals and for the points, right? So we need two different lists. So I'm doing the simplified version here for the sphere, where I'm just sending the same data into both. So you can see it here in the shaders. Then I'm just binding this one buffer, and then I'm basically binding it to both position and normal location, but there's no difference in how I'm reading from it. I'm just reading all the data, both for position and for normal. So I'm going to allow myself to do that while I show you this. Then I'm going to put the more complex stuff in that actually make sure this is kind of an interleaved buffer, where every other kind of, or the first three numbers are a point, then there are three numbers that are normal, then another three that are a point, then a normal, point, normal, and we can read interleaved from them. But right now we're just reading all the data for both. So now we take this and so I'm calling this function set attribute buffers instead of what I originally called, which was just set normal attribute and set position attribute. And I'm sending the buffer ID in. And then when I draw, everything should basically work the same. And let's see, to begin with, that this compiles. Okay, sphere object has no attribute set vertices. Go back into, this is the optimized sphere.
Are you using the original sphere still?
Yeah, no, I seem to have forgotten to copy part of the, I'm using the original sphere, actually, yes, but I seem to have, okay, let's do something like, no, like this. I'm gonna copy this, and I'm gonna redo what I did. Seem to have lost kind of the bottom part of sphere here. So now I'm using the original sphere. Actually, I don't think I'm drawing any sphere in here anyway. But okay, this is working now. Let's go back into the program, put back in this code that actually draws a sphere. Let's see what this looks like. Okay, the texture map is somehow kind of getting spilt all over this. And the reason for that is because we had added textures to our shader. So in the fragment shader, we're using textures. It'd be nice to do something like uniform. Do you remember which? Did you use bool here? Okay. Or float. It's maybe simpler to just use float. U underscore using texture. Then I'm going to go ahead, set an if sentence here. If using texture equals 1. If suing texture equals 1. I'm going to do this, else I am going to do just this. Then I have to go into my shader. I have to make let's steal this one. No, not the texture. Well, it doesn't matter. So this was u underscore using texture, right? Using texture. Let's call this using texture location. Sorry. Here is if using texture. Yeah. Okay. Sorry, yeah. The u underscore. Okay, u underscore using texture. Thank you. It should be u underscore using texture location. And I am going to steal this, and I'm just going to stick it in here. For now, I'm just going to force it in here, that if we're doing the set attribute buffer version, I am going to take using texture location and put it to 0. But if we're using this, I'm going to set it to 1. How about that? So just to see if this works. Not so much. Okay, let's see if we have an error in the shader. Okay, material diffuse undeclared identifier, material specular. Alright, I know why this is, because I'm declaring stuff inside if sentences is not cool in C. So I could actually do this, like so, or let's do it like this. Then go in here and say, I wonder if this works in this particular code. Yeah, the else shouldn't be there. Yes, also I'm doing that. Huh. It's still trying to use the texture here. Sorry, that's the normal sphere, it's not an optimal sphere. Oh yeah, that's true. That is the normal sphere. All right, so for this particular exercise, I'm just gonna take textures off entirely. Anywho, now I have this sphere. There's one thing I kind of want to steal here from other code that I have as well. this. I'm going to go into my update function in here. Basically add these kind of frame rate ticker and frame rate sum here. I'm going to have it write out the frame rate around every second.
You're returning for something. Yeah. The thing above. So you return tax ID, so you're returning before you call it.
Where?
Like I don't think the function above. I don't think the function above is the initialize function.
Ah, okay. True. Yeah, because I've added a function in between there in that version. Okay. Okay, so here we're around, 88, 71, 41. So now what I want to do, again, steal a little bit of code from this, from the draw, and see if this works. Go to our display function. I'm not entirely sure where this will appear. Yeah, let's stick it in here. Let's see which parts of this work. One thing I'm going to do with both the spheres as well, just to simplify this, I am going to take this set vertices function out. Bless. It'll give me some errors here probably. We can fairly quickly find those. Okay, so we don't need to set vertices. That happens inside the draw for spheres now. Okay. Model matrix has no attribute add rotation X. Matrices, what does model matrix have here? Add rotate Z and no other rotation. Okay. We'll steal those as well. Nope, not here. Matrices. Should probably just steal this entire matrix file, but I don't want to. Add rotation X, Y, and Z. I'll probably complain about rotation Z, go in here, replace. So, replace. Okay, auto commented out. Oh yes, haven't made that change yet. All right. Always something. I was going to do sphere here. Just want to draw a bunch of them, kind of fairly close. See what that looks like. Okay. Fine, okay. They're in a good location. So we can see all these different spheres here rotating around that single sphere. Now what I want to do, and we can see the frame rate, it dropped dramatically. It's now just around 20 frames per second. Now I actually want to go even further and say when I load my sphere, my base sphere model here, I'm going to say, let's say 24 slices and 48 stacks. So that's insanely detailed. Now we're going to look at the frame rate. Really, what happened now? Access violation reading. Whew, I've never seen that before, so maybe there's something inherently wrong with my code. Too detailed, well, never mind, let's make it 1224 and see if that... But this probably means, though, that there's some error there that I just haven't experienced yet, or something like that. Okay, so this is bad frame rate anyway. Let's change the position of the light a little bit. That's in display. Are we setting light position somewhere? Let's just do 10 and 10 on the other ones as well. And so it's lit a little bit from the side as well. All right, we're getting there, we're getting there. So okay, this is what we see. It's not very complex, but our frame rate is what? Under 10 frames per second, which is horrible. So now to begin with, we're going to see if our optimized sphere works. Just going to take this out so it's not all too complicated. Number one, make sure I didn't break anything. Number two, change things. Okay, fine. I have my sphere there. Now let's go up here and see if the changes we made earlier to make it the optimized sphere. First, let's see if they work. So optimized sphere. Now I can debug that one. Probably have some crashes and stuff that we need to debug, as always. Ah, okay. It's because I decided this didn't need to be something we store as part of this object or part of this class, because we're only using it to load into OpenGL, and we don't need it anymore. In the regular sphere, we always need this, need access. Sorry? This is vertex count.
Oh, okay.
This is vertex buffer ID. So I think I've got all the vertex array ones. There's always some debugging. Okay, so we've got our sphere, and this is the optimized sphere. The cubes disappeared though. So there's something. Let's see. Ah, that is exactly for the reason that was noted earlier. I can't unbind the buffer inside this function because I need to have it bound when I draw. But after drawing, I need to unbind it. So in the end of draw, I unbind the buffer, and that should mean that the other things that don't use this method should start drawing properly again. So here I have my cubes again. All right, so I have my sphere, and this is the optimized sphere. So now to make this even more exciting, I'm going to go back here. I'm going to put this back in. Save. And I am going to... Should we run this with the optimized sphere now, or first with the other one to make sure it's actually as bad as we thought it was? So regular sphere, running, what, 8 in a circle and then the 1 in addition to it. I did certainly comment in the wrong clause here. It was this one that I wanted. Like so. So regular sphere, 8 plus 1, 9 spheres being drawn at the same time takes our frame rate down to around between 8 and 9 frames per second. Our optimized sphere, I want to make wagers on how good it's going to be, how much better? Anyone? 40 frames per second? 30? Getting close to what I think. I think we're going to hit over 100. Okay, let's first look at it. Does it look smoother? Okay. Well, 60. And what I'm gonna blame that on is the fact that I'm also rendering and sending the video of the screen and all that on my computer at the same time. Because when I did this without doing that, it actually went to 120 or 130 frames per second. Something similar to this. Not the exact same thing, but yeah, those same 8. And actually then they were being rendered the way I originally put them up, as 24 and 48. Which is not double but quadruple the number of polygons in the surface. Doesn't crash. Still around 50. So I quadrupled the number of polygons, but it went from around 60 to around 50. So this is not even the bottleneck anymore. Something else is what's keeping the frame rate down now. So I don't know if you're super excited about this, but I feel this is this is a huge deal. This is a game breaker in making sure that this actually kind of runs properly. And I know you would have all liked to have this running this way with your mazes when you have all these different walls and the frame rate really goes down. So my guess is that if you were to take your maze now and implement it in this way, your walls, so you don't have to actually send the vertex data down every time, but instead just tell OpenGL what vertex data that it already has stored it should use, that just something else entirely becomes the bottleneck. You could make your mazes 10 times as big and it wouldn't have much of an effect because something else would be the bottleneck. So, sorry I didn't introduce this earlier, but I feel we're at the point here where we can kind of understand what's happening. It shouldn't have to take this long, but I just kind of want to do it from scratch and do it, properly through and explain all of these parts. So now this is one thing that we have. What I'd also like to do, before I stop this video, is to revisit this idea, if we go back into base 3D objects, into the sphere, that the sphere is special because we can use the same vertex list for the normals as for the positions. But this is not true for everything, right? So I'm going to introduce here another idea, that instead of using separate lists for the vertices and for the normals, or for the positions and for the normals, we're going to use the same list and we're going to interleave it. So we have one vertex, and that vertex has 6 numbers. So each vertex has 6 numbers rather than 3, but we just have to tell OpenGL where to put these numbers. Like take 3 of those numbers and put them in the position attribute in the shader, take the other 3 and put them in the normal attribute. And then you run the vertex shader. And then after we've run the vertex shader, it goes to the next vertex, which is another 6 numbers. So it's 6 numbers, 6 numbers, 6 numbers. So we have to put the positions and the normals interleaved. So again, we have this nice thing about the sphere that we can just use the same 3 numbers for the first 3 and the second 3 of the 6. So I'm simply going to do for nothing special in range 2, do this. And I'm going to copy that and do this as well. Do you understand what I'm doing here? I'm simply just doubling the same data. I'm putting this in as the vertex, or as the position, and then I'm putting this in as the normal. See what happens now if I just run this. It might crash, I'm not sure. Or just draw nothing. Okay, so we have data that just doesn't make sense. Probably because we have the same numbers next to each other. So we'll have triangles that try to use 2 points, the same point, so they'll have no area, basically, so they're not being drawn. They are being drawn, but they just don't fill in any area. So now we kind of have to change, since this has grown 2 times as big, we have to change in the shaders how we set these up. So we still want this to be 0. We want the position to start at 0. But what we want to do here is we want to do something that's called stride. It's telling us how big steps do I take from the beginning of one vertex to the beginning of the next vertex. If we just put 0 in here, it expects the size of the vertex to just equal the stride. That is, you have one vertex, which is 3 GL floats. And if this is 0, I'll just read those 3 GL floats, and then I'll just read 3 GL floats right after it. You would think that it would be nice to be able to just put something like this in, just put 3, and say, okay, this is going to be a stride of 3 GL floats. So you read 3, skip 3, read 3, skip 3. No. Instead, it says the stride is from the beginning of one vertex to the end of one vertex. So then you think, okay, 6 would be a nice stride here, right? Meaning you read 3, these 3 out of these 6, and then you skip the rest of the 6. Read 3, skip the rest of the 6. Again, no, because this size doesn't look at this GL float. It asks you to put the size in bytes. So this has to be 6 times the size of GL float, which should be, no, this is not. So this is a constant telling OpenGL that it should use GL float. Now I'm trying to use the actual, so it looks like this 6 times the size of GL float. Okay, that's what I wrote here. And the stride needs to be that as well here. Now the only difference would be that they'd be just reading every other vertex, but they're still both reading the same ones. So the last number, I have to say, basically the stride is 6, so each vertex is 6. You're reading 3 GL floats. Each vertex is in bytes, this size, and then I have to tell it where you have to start. So start reading the vertices at 0. You can put none in there, that's fine. But we have to start reading this one here at some other location. Basically, how far into the beginning do I need to start before I start reading 3 GL floats and then kind of skipping the rest of the stride. Does that make sense? So then we get to this weird leftover C pointer, void pointer stuff that we have to accommodate for. And we need to put in this. So OpenGL.glu.ctypes.c void. How did I import GLU? Did I just import it? Or did I do from OpenGLU import star? Let's just do it this way instead. It's nice with some things to have to explicitly. So from OpenGL, yeah. So GLU ctypes.c void p is this operation that changes whatever we put in here into some void pointer offset. However, our void pointer offset will be 3 times the size of GL float, right? Because the first 3 should be the position, then you should start reading this, which is for the normal. And we can also take this, and if we want to be very explicit, we can go in here and say this should start at the beginning, so this would be a void pointer offset of 0. And don't ask me about the void pointer thing and why it's there, just if you want to read the internet about that. So let's see if this works or what happens now. It does. It changes nothing in the actual data we're using. It's just kind of how it's stored. So but now we have separate lists for the normals and for the positions, which means that we can now use this for any other object, not just the sphere. The sphere we could use the other way. Now we actually set this up so we can send any interleaved list of positions and normals into that, and it should work. And that's basically our setup for sorry, I'm thinking here. Our setup for actually starting the 3D mesh loading, the 3D model loading. I think I'll stop this video here though. It's plenty in one video. I'm going to take a short break and then I'll just make another video with another title to look at the mesh loading.